The solution for number 1 is B. The only one of the algebraic expressions that is equivalent to 2m minus 13 is B. Let's go ahead and talk through why. So let's start off with B. Negative 5m, 6m, 3m, and negative 2m are all what we call like terms. They all share a variable of m. I'm going to combine the two positives together, 6m and 3m, which is 9m. Then what I'm going to do is take away 5 and take away 2. So 9 minus 5 is 4m. 4m minus 2m is 2. Then what I'm going to do is combine together the constants, a positive 2, a negative 8, and a negative 7. A negative 8 and a negative 7 is negative 15, and then you'd add in that 2 at the end, which would give you a negative 13. Sometimes, so I don't forget which ones I combine together or not, I cross them off. Negative 8 and negative 7 is negative 15. Add 2 again is negative 13. And when I did the terms for the m's, 6m plus 3m is 9m, cross those off. Minus 5 is 4m. And then I have to take away 2 more to give me 2. Let's go ahead and take a look at C. I'm going to circle the constants 2, negative 8, negative 3, and negative 4. So I'm going to combine together the negatives. Negative 8 and negative 4 is negative 12. When I combine it together with that negative 3, this would be negative 15. And then when I add 2, that's where I ended up getting a negative 13. Let's go ahead and take care of the m's. Negative 2m, negative 10m, negative 2m, because they're all negative and I'm combining them together, the final answer is going to be negative. Negative 10 combined together with negative 2m would be negative 12m. Negative 12 minus 2m would be negative 14. Let's take a look at the top. Before I can get started with this one, I see the opposite of a negative, so I'm going to rewrite this. 15m plus 6 minus 9 plus 3m plus 10. Because the opposite of a negative is a positive, I'm going to combine together the m's. 15m, 3m is going to give me 18m. I'm going to combine together the two positive constants. 6 and 10, which is 16. Take away the 9 would get you 7. Let's go ahead and look at target 2. When I look at a problem like this, I see distributive property. So I need to bring down the 12, and I'm going to multiply everything inside that parenthesis by 1/4. Remember, if I take 1/4 of a number, let's say 8, what that means is I'm doing 8 divided by 4. I'm trying to figure out how many groups of 4 are in 8. The reason why I'm going to bring the 12 down and not combine the 12 and the 1/4 together is that in order of operations, we never add before we multiply. So let's go ahead. 1/4 of 8x is going to be 2x, because really what I'm doing is dividing each one of these by 4 inside the parenthesis. 1/4 of negative 4, again, 4 divided by 4 is 1, but because I'm multiplying a positive and a negative together, my answer would be as well. The reason why I did not combine an 8x and a negative 4 together is because they are not alike. And I'm going to bring down that negative 5x. When I combine together my like terms, 2x and negative 5x, that's going to give me negative 3x. And then I'm going to go ahead and combine together the positive 12 and the negative 1 to give me a positive 11. Let's go ahead and take a look at this bottom target, target number 3, where we're solving inequalities and then graphing our solutions on a number line. What we're going to do is solve this two-step inequality just like we would a two-step equation. We are still going to use inverse operations and show equality, even though I know the left-hand side of this inequality is smaller. So what I'm going to do is add 5 to undo all the addition and subtraction where the variable is. I would have a 6, negative 5 and positive 5 eliminate, and I'm going to bring down that 3x. The next thing I'm going to do is undo the multiplication, and I'm going to divide both sides by 3, again to show equality. 3 divided by 3 is 1x. 6 divided by 3 is 2. Now, when you solve inequalities, instead of bringing down an equal sign, you're going to bring down the inequality symbol. And what this tells me is that the solutions that I plot on the number line all should be less than or equal to 2. 2 is what we call our boundary number. And what this tells me is that no numbers for the solution could be greater than 2, but they could be equal to or less than. So when I see an equal to symbol, a less than or equal to, or a greater than or equal to symbol, I want to put a filled in dot right over the number line, just like I would if it was x equals 2. So that's what I'm going to do right here. And then when it says x is less than 2, or less than or equal to 2, I need to find numbers on my number letter smaller than 2, which is this region over here. If I wasn't sure, I might pick a number on the number line and plug it into this inequality just to test. 0 is less than 2, and sure enough, it makes the inequality true, so I'm going to shade in this direction. That means I have an infinite number of solutions all within that range. I'm going to test the 3 inside that inequality just to prove why I would shade on the left. I'm going to put x is less than or equal to 2. I'm going to go ahead and plug that 3 right in here. And as you can see, I would have an inequality that was false. So I would not want to shade in that region.